I'm not even sure that I can help him figure it out later. It's like today could be a day where I could really lose Derek. It's a very, very important day. I get he probably could have taught himself the Pythagorean theorem without me. Heck, he probably could have, with the converse notes, taught him the converse of Pythagorean theorem without me. But sadly, he needs me for this next section. So today is the day. And if I were you and I didn't understand, when I went home, I would watch the video again. Because you want to make sure you have it. Because today is really important. Okay, let's go over this bell ringer. I was being lazy and I said you could skip number 1. There is the answer. Now, I could go into what I need is something that multiplies to give me 42. 14 times 3 is 42. I need something that adds to give me 17. 14 plus 3 is 17. But I swear you did factoring in Algebra 1. And today we have such an important thing to do in geometry. I really can't go too deep into that. The next one's the same way. So I need two numbers that multiply to give me 40, good grief. Multiply to give me 20 and add to give me a negative 9. But I knew you can handle number 2 because there are options. So for instance, I know it's not H because 7 times 2 is 14, not 20. What is the correct answer choice? Now, again, we need the two factors to add to give me a negative 9. Negative 4 and negative 5 is a positive 20. Negative 4 and negative 5, when added together, make a negative 9. If you need more practice factoring, please ask. Eventually, we're going to need this skill to come back to you. But at the moment, I need so many other skills, I'm going to let it go. Okay, so you got the handy-dandy little blue slip. I'm going to use colors on it today. I'm going to do so many examples, I might explode. I'm going to do the examples on the blue thing. I'm going to do the examples on the notes. And I have, of course, practice problems and a little maze for you to practice with to make sure you have it down. Before I go any further, let me remind you that eventually I told you there would be a test, 2 sections and then a test. So today we're doing 45, 45, 90. Tomorrow we'll do 30, 60, 90. We'll probably practice both on Friday. More than likely what's going to happen is we'll review Monday and there'll be a test on just the 2 sections, just on special right triangles and just on Pythagorean theorem next Tuesday. Now everyone in the room has almost got their life right with Pythagorean theorem. I only have one person who wants to always make x be the C, when we know the C has to be a specific part of the triangle. Can you remind me what that word is for what the C is? Ellie said it. What is this part of the triangle called? The thing that's across from the right angle. It is called the hypotenuse. And if you want to spell it all the way out, you can. I'm just going to put HYP. Now this little blue sheet is going to be yours, and you can make it as useful as you want. I'm going to, because I already offered up to 18 bonus points on this next test, so a -5 wouldn't be much. I'm going to offer Harrison an option. He can use this blue sheet on the next test, but he's going to give me 5 points for it. So Harrison's already in a 95. I say that, and Harrison knows that I'm a sucker, and if he writes a good enough justification answer, I'll give him some bonus from that. So as long as Harrison's confident with his justification skills, he can probably earn back those 5 points I'm going to steal. But the moral of the story is I would keep out with my blue handout. I would make it useful to me, because if you want to lose 5 points but still get to use it, it's pretty smart, you can on this next test. Okay, so today we need to talk about what we call the other parts of the triangle. What do we call, like, the bottom and this side? They both have X's on them, but we need a term. What do we call them? We do call them legs or sides. I'm going to call them legs, but sides would work too. So there's one leg. Here's another leg. Okay, so we have the hypotenuse, and we have 2 legs. Everyone in the room should be able to identify the hypotenuse. I always draw my arrow to help me find it. The only thing we've done lately that was confusing was the converse coloring page, because some of them didn't draw in the right angle for you. You had to figure out the spot to draw it in at. That'd be the only potentially confusing thing with the silly hypotenuse. Okay, so a triangle adds up to 180 degrees. If you do 90 plus 45, you get 135. 180 minus 135 is 45. So this is a 45, 45, 90. If you have a 90 degree and a 45 degree, the other spot has to be 45 degrees because it's a triangle. Triangles haven't changed. They're always going to add up to 180 degrees on the interior. So if you want to write in the missing 45s, you sure can. Does not matter to me. Okay, so not only do two angles match, but since two angles match, two sides match as well. We talked about how an angle goes with the side across from it. That's why the 90 is the hypotenuse. It's the biggest angle, and the hypotenuse is the longest side. There's a reason they're across from each other. So this 45 is going with this side that has an X on it, and this 45 is going with this side that has an X on it. So not only do two angles match, but the two legs match. Okay, so since the two legs match, what kind of triangle is this? It is a right triangle. I need another word. I'm going to put right triangle, but I'm going to put another word in front. Yes, that's the word I want. What is it? It's isosceles. Two legs match, so 2 out of 3 sides, it's isosceles. It's an isosceles right triangle. Very good, Catherine. And Catherine's already got it, but I'm going to write this in case you want it on your handout. The legs are congruent. 2 of the angles match, so the legs match. So what's going to happen is they're going to give you one leg, like on this example, and we see that leg's 3, so I can already figure out the other leg. It's going to be 3. That's easy. Or for instance, on this other example, one leg's 2 square roots of 3, so this other leg, it has to be 2 square roots of 3. The 2 legs match. So if you know one leg, you automatically know the other leg. The issue is that somehow, given just that leg, I should be able to solve for the hypotenuse. And there is a relationship. Okay, so I'm going to write 2 different formulas. They're really one and the same, but it just depends on your perspective in life. So if you're given a leg, like we are in these top 2 examples, to figure out the hypotenuse, you'll do hypotenuse is equal to the square root of 2 times that leg. So if you're given a leg, to figure out the hypotenuse, you multiply your number by the square root of 2. So for instance, on my example here, for this hypotenuse, I'm going to do square root of 2 times my leg. Well, my leg is 3. So my hypotenuse is really 3 square roots of 2. Are there any questions about that first one? So now Harrison's realizing I probably want to use this blue sheet because Ms. Compton's giving me the formulas. Otherwise, I'm going to have to know those and understand them on my own. Okay, so I'm going to do the exact same thing on this next one because, again, I'm given a leg. So to figure out this hypotenuse, I'm going to do square root of 2 times my leg. Well, my leg is 2 square roots of 3. Now, here's the part that you're not going to like. You already had an algebra class, so I love you dearly. You should already know that you multiply the numbers underneath the house together. So it ends up being 2 square roots of 6. Now, Carrington's not going to miss out on too many points if she misses this last step. I'm mostly looking to see that she's figured out who to plug in the correct formula, as my geometry self normally is. But if she's wanting all her points, she has to go the one step further. You multiply the numbers on the outside. 1 times 2 is just 2. You multiply the numbers under the houses, under the radicals. 2 times 3 is 6. Are there any questions on our top 2 examples? What is different about our bottom 2 examples? It's still 45, 45, 90. They gave us the hypotenuse. So we have to have a different strategy. So my formula works if I'm given a leg. Now I'm going to rearrange it in case I'm given the hypotenuse. If I'm given the hypotenuse, I need to figure out a leg. So what I'm going to do is the leg is equal to the hypotenuse. Instead of multiplying by the square root of 2, I've got to take the square root of 2 away, so I'm going to divide by the square root of 2. Again, really these two formulas are one and the same. These are really pretty much saying the same thing. It's just going different ways. So if you're given the leg and you need the hypotenuse, you multiply by the square root of 2. If you're given the hypotenuse and you need a leg, you divide by the square root of 2. So it's just up to Derek. Am I multiplying by square root of 2 or am I dividing by square root of 2? That's really all we're saying today. I'm either multiplying by square root of 2 or I'm dividing by square root of 2. Okay, so my bottom two examples, I'm given the hypotenuse. So to figure out this leg, I'm going to need to take my hypotenuse, which is 4, and I know that because that's the number across from that right angle, and I'm going to divide by the square root of 2. I'm going to do the exact same thing on this example over here. To figure out my leg, I'm going to take my hypotenuse, which is 10 square roots of 2, and I'm going to divide by the square root of 2. Now, let's face it, Ms. Compton is not going to leave her answers like this. This is not how a math person would leave their answers. Thankfully, the one on the right is going to work out nicely for us because it looks scary because it already had that square root of 2 and now we're dividing by the square root of 2, but what's going to happen? Yes, they will cancel out. So it ends up just being 10. So the right one looks scarier, and it's actually not scary at all. So I have 10 for x, and obviously y is also 10 because the legs match. You find one leg, you found the other. So I've got 10, 10, 10 square roots of 2. And that makes sense. But on this one over here, I'm not going to leave it with that square root in the denominator. Harrison's going to miss out on some points if he does that. We don't allow that. It's like when we don't allow negative exponents. Why math people have such rules, I wish I could explain. I did not invent math. I just use it a lot. So to get rid of things, you multiply by 1. But really, I'm multiplying square root of 2 over square root of 2 is 1. But really, I'm multiplying by this, and I know that seems crazy, all because I can't handle that in the denominator. This is an issue for me. I have an issue having that square root in the denominator. So I can't. I have to fix it. So to fix it, I multiply by 1, which is really square root of 2 over square root of 2. And then so in the top, I get, my leg is still equal to that. I get 4 times square root of 2, so I get 4 square roots of 2. But in the bottom, I get square root of 2 times square root of 2, which is square root of 4, because 2 times 2 is 4. Am I done? No, I told you my issue was having that radical in the denominator. Do I still have a house in the denominator? So I'm really still not done, but what is the square root of 4? You know that, it's 2. So I really have 4 square roots of 2 over 2. And Lord knows I could simplify that one last time. 4 divided by 2 is 2. So my answer is actually 2 square roots of 2. So again, this one was the most complicated. It looked the easiest. It looks so nice. You're going to learn that the ones that have a pretty hypotenuse are the biggest pains to solve. So it had a pretty hypotenuse. We needed the leg, so we had to divide by the square root of 2. When we divided by the square root of 2, that was an issue. We couldn't leave our answer like this. We cannot leave our answer with that square root in the bottom. We multiply by 1 in order to fix this issue. If I multiply straight across, 4 times square root of 2 is 4 square roots of 2. Square root of 2 times square root of 2 is square root of 4. I know the square root of 4, that's 2. I know 4 divided by 2 is 2. So this one is the most complicated, I agree. But again, Harrison knows that now he has a complicated one listed on his handout. So if he's willing to drop from that 100 to a 95, he can use this on our next assessment. Okay, I have 1,000 more to work with you, so get out your little sheet. We're only doing the front side, I believe. We're only doing the 45, 45, 90s today. Lord knows I can't do more than that. Dear. Is this where you wanted me?
I want to go back.
Oh, okay. What number can I put on this leg? Why can I put a 9 on this leg? The two legs are going to be equal to each other. So at least Carrington's going to do that. I know it didn't say to, but Carrington wants to show me she knows what she's doing, so she's going to at least do that. What part of the triangle are we solving for right now? Okay, so we were given the leg, and we need the hypotenuse. So we had a formula that said, given leg, what are we supposed to do? The hypotenuse is equal to what? Square root of 2 times your leg. What was our leg? What is our leg in this example? 9. So I'm going to do square root of 2 times 9, square root of 2 times 9, and I get 9 square roots of 2. Not a problem. Okay, I go to are there any questions about that? Today would be today to ask me, like, Miss Compton, I really don't know where the hypotenuse is. And I would say, P.S., it's always across from the right angle. Okay, on the next example, are we given the hypotenuse or are we given a leg? Okay, we were given a what? Okay, what are we given? Make me feel better. Humor me. We're given a leg. Okay, so I need the hypotenuse. So I'm going to multiply the leg times square root of 2. So 6 square roots of 2 times square root of 2. I'm running out of room. So I'm going to end up getting what? 6 square roots of 4. What Ellie's doing is she multiplied the numbers on the outside. 1 times 6 is 6. And the numbers under the radical. 2 times 2 is 4. Is Ellie done? Is she done? Why is she not done? What is the square root of 4? So what's 6 times 2? So if Ellie saw that to begin with and she jumps to the end, that's fine. What Ellie needs to do to show me to get her points is what formula she's using. And she probably wants to label the triangle. I mean, heck, even if Pierre gets stuck and he can't solve the triangle, he can at least label leg, leg, hypotenuse, and he can at least list what formula he's supposed to be using. So he can't get all the way to the final answer. He can at least show me most of the steps and get most of his points from me. Okay, we get to our third example. What were we given, a leg or a hypotenuse? So let's look at it. I heard hypotenuse, but it wasn't that loud. Are we sure? What were we given on that third example? Okay, so we were given the hypotenuse. So we need a leg. To figure out a leg, we're going to take the hypotenuse, and instead of multiplying, we're going to divide by the square root of 2. So in my case, I'm going to do 8 divided by the square root of 2. I cannot leave my answer like this. Anytime I see a pretty number on the hypotenuse and I'm solving for a leg, I'm like, darn, those are the ones that require work. I cannot leave my answer like this. I do not like having that square root in the denominator. I have to fix it. In order to fix it, you have to multiply by 1. So I'm really multiplying by the problem in the numerator and the denominator. That's what makes it okay. So you multiply by whatever your issue is. My issue is that darn square root of 2. So I'm going to multiply the top and the bottom by the darn square root of 2. Okay, so I go across. 8 times square root of 2 is 8 square roots of 2. Square root of 2 times square root of 2 is square root of what? Yeah, it's square root of 4. But I know the square root of 4. What's the square root of 4? So I have 8 square roots of 2 over 2, and I'm still not done, although I am out of room. I can simplify that again, and what would I get? Yeah, 8 divided by 2 is 4. So my final answer is 4 square roots of 2. So I've got to get rid of that issue. So I multiply by the top and the bottom with that issue. I multiply straight across. 8 square root of 2, 8 square roots of 2. Square root of 2, square root of 2, square root of 4. I know the square root of 4, it's 2. 8 divided by 2 is 4. This is how I'm getting my final answer. Now, once you work enough of these, if you recognize that there's a pattern, because there is, if you recognize the pattern and you automatically know the answer. That's fine. That's fine. Just be warned, if you missed it and I don't see any work, it's kind of hard for me to give pity points. So if you notice there's a pattern going on, because there sure enough is, for instance, 8 divided by 2 is 4, and the answer was 4 square roots of 2. 12 divided by 2 is 6, and it was 6 square roots of 2. Like, there's something going on, I agree. But not everyone's going to recognize that. So if you do, go for it. Otherwise, I'm a formula girl. I can formulate it all day long. Okay, flip to the back. There's one more on the back top I forgot about. Okay, what were we given? A hypotenuse or a leg? Okay, so we're given a hypotenuse. So the formula I'm going to use, because I'm solving for the leg, is I'm going to take my hypotenuse, which is 6, and I'm going to divide by the square root of 2. I can't have that square root of 2 going on in the denominator, so I multiply the top and the bottom by the square root of 2. I multiply straight across. 6 times square root of 2 is 6 square roots of 2. Square root of 2 times square root of 2 is square root of 4. I know this keeps happening over and over again. That means we're doing it right. The square root of 4 is 2. 6 divided by 2 is 3. So I end up getting 3 square roots of 2. So for both legs, the answer is 3 square roots of 2. And for this leg, it's 3 square roots of 2. Are there any questions about this? I could do 1,000 more, but let's face it. Either you're kind of getting it or you're not, and you need to talk to somebody. Okay, I have a